Hello, let's do checkpoint 5.12. They want us to find the volume of the solid bounded above by this is a plane, 10 minus 2x plus y, and over a region enclosed by the curves y is equal to 0, y is equal to e to the x, and then x goes from 0 to 1. So e to the x goes up like this. This is y equals e to the x, and 0 is the x-axis, and here we're going to go from 0 to 1. So this is the region that we're talking about. And in terms of trying to set up a double integral over this region, I think it's best to do this as a type 1 region where we integrate with respect to y first. So we'll call it type 1. And we're going to integrate with respect to y first, and then with respect to x. And to integrate with respect to y first, we draw a line parallel to the y-axis, and we note what functions y equals to functions that we're going to enter into the region and exit. So we're going to enter through 0 and exit through e to the x. And then meanwhile, our x limits go from 0 to 1. So that's a pretty simple setup, I think. And then now we want to set up our double integral. So our double integral over the region R, if we call this region R, and our function is 10 minus 2x plus y in dA generically. And then we'll set up our double integral with these limits that we just found. So we have 10 minus 2x plus y. We're going to integrate this with respect to y first, and the y limits are going to go from 0 to e to the x, and then we'll go with respect to x, and your x limits go from 0 to 1. Okay. In here, it's a pretty simple integral. We get 10y minus 2xy plus 1/2 y squared. We evaluate from 0 to e to the x. When we put 0 in here, everything disappears. These are y limits, by the way. So make it explicit, we'll say y equals to 0 to e to the x. And again, when we put 0 in there, everything disappears, so we only would care about what happens when we put e to the x in for y. And so we'll have that minus 2x e to the x plus 1/2 e to the 2x. Okay. All right. This thing looks like it's going to be some... we can combine that, and we'll note that there's going to be some integration by parts involved there. So let's just say I'm just going to put it into an integral calculator. Anyways, when you get to here, you will have 0, an integral from 0 to 1 of this thing that we just found. 10 minus 2x will factor out an e to the x from there, and then 1/2 e to the 2x dx. And like I said, this thing will involve integration by parts, and so I'm going to skip over that and just give you the solution that I ended up getting. And the solution that I ended up getting was 10e plus 1/4 e squared. Let's find a pen that would write here. 1/4 e squared and minus 49 over 4. Okay. So all this will eventually equal to about 16.7801. All right, that's it. I hope that helps.